Ladies and gentlemen, this is Miss Humbert here. Today we're going to be doing the Unit 6 Quiz 2 review, so we're going to get you kind of ready for that quiz. But before we start, I would actually like to just take a second and go over some of the formulas that you're going to need for your quiz. And you can write these on the top of your quiz before you start taking it, so make sure you have them written down on the review itself. So, for exponential growth. For exponential growth, the formula you're going to use is c times 1 plus r to the t power. So that's for exponential growth. For decay, it's going to be that should be a parentheses there, 1 minus r to the t. Now both of these are equal to y, or basically the amount that you want to get. Remember that c represents your starting value, r represents your rate, and if it's a percent, you always convert it to a decimal, and t is going to represent the time. So now taking a look at that compound interest formula. You remember that you use the compound interest formula if it ever says the word compound. So we're going to do y is equal to p times 1 plus r divided by n raised to the n times t. You do not need to memorize this equation, just have it written down so you can copy it over onto your quiz. So n is going to represent the number of times per year. R, again, is going to represent your rate just like it did up there. And this n is the same as this n down here. T still represents how much time is passing. And the P is going to be the start value, how much money you're putting in at the start. Now let's go ahead and let's start applying this. So taking a look at number 1, the population of Atlanta, Georgia in 2000 was 7,568,000 people. The population has been growing at a rate of 0.2% per year. Even though the percent is a decimal, you still have to convert it away from a percent. So you're going to move it left 2 places. So then our rate is going to be 0.002. So our starting value is 7,568,000. And then we're going to do 1 minus 0.002, and then we're going to be raising that to some t power. We don't know the time yet. So then for our final answer, or no, it's growing, isn't it? Okay, so because it's growing, it's exponential growth. I forgot about that part. I was so excited about the math. So growing means you're going to use growth, so you're going to be adding. So then when we write out our official equation here, we're going to add those two together and we get 0.002, and that's going to be raised to the t power. So that right there is going to represent the equation for the population. So now we need to actually figure out how many they're going to be in 2015. So in order to figure out the number of years, we need to figure out how many years passed between 2000 and 2015. So we can do that by subtracting 2015 minus 2000, and we get 15. So now you can go ahead and you can plug that into your calculator. And remember, when we're talking about people, you want to round to the nearest person. You don't want to have a decimal of a person. So we have 7798246. So now let's split that up. So we have 7,798,246. And it is a word problem, so don't be losing points on forgetting the label. So we need to label it people. Now, let's go ahead and let's take a look at number 2. It says the amount of money Walmart made off of printing was $70,000 in 2012. Its value has depreciated. Now, depreciated indicates going down, so that means we need to use the exponential decay equation since the arrival of the digital cameras at a constant rate of 13% per year. So we have this 13%, so we need to move the decimal point left 3 places. So that's going to make our R 0.13. So we're going to take our starting value of 70,000, and then we're going to take 1 minus our 0.13. Now don't forget to subtract that from 1. You don't just want to plop 1.13 in there. Then we're going to raise that to the t or to the x. So now when I set up my equation, I'm going to have y is equal to 70,000, and then I'm going to do 1 minus 0.13, which is going to give me 0.87, and that's going to be raised to the t power. So this right here is your final equation. So now we're going to use said equation for figuring out how many sales there were after 15 years. So that's convenient. We didn't even have to subtract years. It gave us that we want to plug in T as 15. So you're going to go ahead and punch that into your calculator. Again, you might want to be doing it with me so that when I give the answer, you make sure you're plugging it in correctly. So when you do that, you end up getting $8,667.36. Now, whenever we're talking about money, you want to round to 2 decimal places. So you'll look at that third decimal place to figure out how you need to round it. Okay? Let's take a look at number 3. So for number 3, we're going to be doing a compound interest formula. When you read through it, it says determine the amount of an investment if $1,000 is invested at an interest rate of 6%, which as a decimal is 0.06, compounded. Okay, so that's how we know we need to use the compound interest formula because it flat out says compounded in the problem. Semi-annually. So semi-annually means twice a year. So that's going to be that n is equal to 2 for 13 years. Okay, so let's go ahead and let's plug this in. So for the compound interest formula, we have our starting value. And then we're going to do 1 plus our rate, which is 0.06, divided by the number of times per year. Well, since it's semi-annually, it's going to be 2 times per year. Now, that's going to be raised to the number of times per year, which we decided was 2, times the number of years, which we decided, which we're using 13. So remember that on these, you need to take the extra step of multiplying out the exponent. So I'm going to rewrite this out, and then before I plug in anything in my calculator, I need to figure out what 2 times 13 is. Well, 2 times 13 is 26. So now we have 1,000 times 1 plus 0.06 divided by 2, all of that raised to the 26th power. Be cautious of needing to potentially put a time symbol in there if you're using a crappy calculator. So when you do that, you end up getting 2,156.591. So when we talked about money, we said, okay, you need to round it to 2 decimal points. Well, when I look at that third decimal point, I see that it's 5 and under 5, so that means that I can just cut this off and leave it as 0.9. So again, money means you need to use 2 decimal points. So now let's go ahead and let's take a look at number 4. It says that the population of polar bears living at the Arctic has been declining at a rate of 0.3% per year. Again, that means you need to convert it into a decimal. So your rate is going to end up being 0.003. Every year since 2004. In 2004, okay, so that's going to represent our starting point is in 2004. It was estimated that 200,253 polar bears were living in the Arctic. So we want to write an equation. So it says that they're declining. So declining implies going down, which means I need to use exponential decay. So I'm going to do 200,253 and then 1 minus 0.003, and that's going to be raised to some x power, because again, or t, either one, I'm still writing out that equation. So to finally write out the equation, I have y equals 200,253. 1 minus 0.003 is 0.997, and that's going to be raised to the x power. So this right here represents the equation that would represent this situation. So now we need to figure out how many polar bears there's going to be in 2045. So I need to take 2045 and subtract 2004. And when I do that, I get 41 years. So we're looking at 41 years later. So we're going to have y is equal to 200,000, 253, not just 200,000, 253 times 0.997 to the 41st power. So then I can go ahead and plug that in my calculator. And when I do that, I get 170,043.7. Now, we don't want to have to define what 0.7 of a polar bear is. That doesn't really make sense. So what we're going to do is we're going to round. Since this 0.7 is 5 or greater, we can take this 3 and make it larger. So I have 177,044. And I want to make sure I label that polar bears. You want to make sure you give every word problem a label. Those are easy points. Don't lose them. So let's go ahead and let's take a look at number 5. In the city of Farmington, house values go up at an annual rate of 3%. So I'm going to write that as 0.03. Okay. Okay. Susie's family bought a house for $39,000 in 1995. So 1995 is going to represent our starting point. So let's write that equation. So it's starting at 39,000. And then it's going up, which implies exponential growth. So we're going to add that rate of 0.03, and we're going to raise it to some year power. So to write out that equation, I'm going to have 39,000, and then 1 plus 0.03 is 1.03 to the x power. So this right here is the equation that represents this situation. So now I need to figure out how many years passed between 2023 and 1995. So I'm going to take 2023 and subtract 1995. Now, when I do that, I end up getting 28 years. So that's how many years passed. So I'm going to take this equation that I have, and I'm going to plug in 23 years for the x for the number of, or 28 years, sorry, for the number of years. So then when I plug that into my calculator, I end up getting 89,229.179. So again, that's 3 decimal points. With money, you want to block it at 2. So this 9 is greater than 5, which means I need to round the 7 up. 7 up. So then this is going to become 0.18. I'm going to put a little dollar symbol on it because I'm talking about money. Money always has 2 decimal points. Last but not least, let's take a look at number 6. It says determine the amount of investment if $400 is invested at an interest rate of 3.25% compounded weekly for 5 years. Okay, so weekly means your N is 52. A rate of 3.25%, we're going to move that decimal left 2 places, so I'm going to get 0.0325. 5 years, $400. I'm ready to rock. I notice that it says compounded, so I'm going to use that compound interest formula. So I'm going to do 1 plus my rate, which is 0.0325, divided by the number of times per year. So since it's weekly, it's 52, raised to the number of times per year times the number of years. So now what we're going to do is I'm going to take the extra step to actually multiply out the exponent. Remember, that's really important. You don't want to do that step all at once in your calculator because it will give you the wrong answer due to order of operations. So 52 times 5 is going to give us 260. So what you're going to get in your calculator, again, maybe check it along with me. Make sure that you're getting these answers so you know you're typing it in correctly. The third digit is 5, which means I need to round this 5 up because money always deals with 2 decimal points. So I get 470.56. So $470.56. And that concludes your review video for today. Let me know when you're ready for the quiz. Thanks for listening.